Hi, welcome to Lesson 10-1. Tonight we're going to be talking about adding and subtracting fractions with like denominators. That would mean I would have a fraction like 2/4, and I would add them or subtract them, and 1/4. Both denominators would be 4.
Mathematicians, in this lesson, you will learn how to add and subtract fractions with like denominators by recognizing that the addition or subtraction of fractions is the addition or subtraction of pieces counted, but not of the pieces in the whole. You already know that one of the ways to express a non-unit fraction is to break it into its component parts. For example, 5/6 can be broken down into 5 1/6 pieces because putting 5 1/6 size pieces together will yield an amount that is the same value of 5/6. If I look at my picture, I see that I have 5/6 shaded in here and 5 1/6 pieces. The 5 pieces should fit perfectly on top of the 5/6 I've shaded. This shows me that adding 1/6 times is the same value as 5/6. This knowledge will help you add and subtract non-unit fractions because it will allow you to think about addition and subtraction as the putting together or breaking apart of fractions into sets of other non-unit fractions. Let's say I eat 2/6 of a pizza and my friend eats 1/6 of a pizza. I would like to know how much pizza we ate together. I am adding because I'm putting values together. Adding is counting up from one value to the next. My numerator tells me how many pieces to count, while my denominator tells me how many pieces there are in one whole. I remembered a minute ago that I can put together pieces of unit fractions to make non-unit fractions of equivalent values, and the same thing is true here. Thinking about my pizza, I realized that if I ate 2 pieces and my friend ate 1 piece, then together we must have eaten 3 pieces. That means I should add my numerators together when I add fractions. The denominator of 6 is a little different. Remember that 6 tells me how many pieces there are in a whole pizza. Just because I ate some pizza and my friend ate some pizza does not mean that the number of pieces in our pizza changed. Taking pieces of pizza out of the pan just means that more pieces are gone, but not that the number of pieces that there were when the pizza was full differed. That means that when I add fractions, my denominator should not change. When I ate 2/6 and my friend ate 1/6, my friend and I ate 3 out of the 6 pieces that there were in the pan, or we ate 3/6 of the pizza together. I do the same thing for subtraction. Let's say that instead of wanting to know how much pizza we ate together, I want to know how much more pizza I ate than my friend. I am subtracting because I want to know the difference between values. Again, I know that my numerator tells me the number of pieces I want to count. So when I ate 2/6 of the pizza, I counted or ate 2 pieces. And when my friend ate 1/6, she counted or ate 1 piece. The difference between 2 and 1 is 1, so 1 is my numerator. Just like before, even though I ate 1 more piece than my friend, it does not mean that the number of pieces in our whole pizza changed, or that our denominator should change. I ate 1 more 6th size piece than my friend. Therefore, I don't subtract my denominators either. In addition and subtraction with fractions, I add or subtract my numerators because they tell me what to count, but I do not add or subtract my denominators because the number of pieces it takes to make a whole does not change. Let's try this in a problem. Michaela ate 7/12 of her orange before lunch and 4/12 of her orange after lunch. How much of her orange did she eat? I know I want to add here because Michaela ate some orange before lunch and ate some more after lunch, and I want to put the amount she ate together to see her total amount eaten. If I think about eating an orange, I realize that if Michaela started with 12 pieces in her orange, it doesn't matter how much she ate. She would still only have 12 pieces in the whole thing. This reminds me that I will not add my denominator when I operate. It will stay at 12 no matter what my numerator becomes. My numerators are a different story. Michaela started by eating 7/12 of her orange. 1, 2, 3, 4, 5, 6, 7. And then she ate 4 more of the 12 pieces. 1, 2, 3, 4. In all, Michaela ate 7 plus 4, or 11 pieces of her orange. Michaela ate 11/12 and had only 1/12 of her orange left. You just learned how to add and subtract fractions with like denominators by recognizing that the addition or subtraction of fractions is the addition or subtraction of the pieces counted, or the numerator, but not of the pieces in the whole, or the denominator.
All right, let's take a look at a few more examples. 1/8 plus 2/8. My denominator is 8. It stays the same. 1 plus 2 is 3. The last thing you need to look for is it in simplest form? I can't divide 3 and 8 by anything, so it is. So 1/8 plus 2/8 is 3/8. 3/10 plus 5/10. My denominator is going to be 10. 3 plus 5 is 8. Is 8/10 simplest form? It is not. I can divide both 10 and 8 by the number 2. 8 divided by 2 is 4. 10 divided by 2 is 5. So 3/10 plus 5/10 is 4/5. My answer is reduced down into simplest form. 1/2 plus 1/2 plus 1/2. All my denominators are 2. 1 plus 1 plus 1 is 3. This one is not in simplest form because it is an improper fraction. Remember, with improper fractions, the numerator is bigger than the denominator. What I need to do is I need to think how many 2's are in 3. There's 1 whole 2 in 3. I have a remainder of 1, and my denominator stays 2. 1/2 plus 1/2 plus 1/2 equals 1.5. Now let's move on to some subtraction. 6/7 minus 3/7. My denominator is going to be 7. 6 minus 3 is 3. Is that simplest form? It is. 4/6 minus 1/6. My denominator is going to stay 6. 4 minus 1 is 3. Not simplest form. What can I divide 3 and 6 both by? If you said 3, you were correct. 3 divided by 3 is 1. 6 divided by 3 is 2. 4/6 minus 1/6 is 1/2. There are 2 that I would like you to do. Pause it, figure out the answer, and then press play. Make sure you write these in your notes under 10-1. All right, let's see how you did. 3/8 plus 3/8 would equal 6/8. Although both of these can be divided, what can they be divided by? They can both be divided by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. Your answer should have been 3/4. The last one. 7/9 minus 2/9. My denominator would have been 9. 7 minus 2 is 5. I cannot reduce it down any, so my answer should have been 5/9. I hope you have a great night. I hope you understand how to add and subtract fractions when they have the same denominator. We will see you tomorrow for some more practice.